So I fitted the gib up to the slide, and I did some work on the slide itself, deburring and edge breaking, and stoned everything very careful, and I got it to a nice sliding fit. I could set it a little bit tighter, but that has to wait until I get the screw fitted. Speaking of the screw, this is the original Acme thread, 14mm diameter, 3mm thread pitch, and it has a horrible finish. It looks like it had been chiseled out and finished with a belt sander. So I ordered a new medium grade rolled Acme screw, just a half a meter thick. Cut it off, threaded the end internally, took a piece of steel. This is just free cutting mild steel, and I threaded this end too, and I Loctited and screwed them together with a piece of 10.9 all thread and Loctite 648. So these two parts are never coming apart again. And then I machined it down to a very close diameter for the bearing. As you can see, that's a pretty darn good sliding fit. Now I need a spacer bushing, and the hand wheel and the screw will pull it all together. The bearing I'm using here is the double row angular contact bearing with a solid internal ring, so it has the preload built into the bearing. It's not adjustable at all. But they come with about an axial play of 1 to 3 microns, or something in that range. And that's plenty good for a compound slide on a lathe. And I fitted the bearing, it's pressed in there, and it will be held in place anyway because this gets screwed against the compound. This is the bearing, way nicer action than the two axial bearings that were in there before. I already threw them away because the balls in there were about the shape of an egg or a rock, a rolling rock. Roll. So yeah, that's what happened. I will keep the original nut because that looks pretty darn good, but the screw was just terrible. Okay, here is the original screw. The bearing end and the surface finish is quite rough. This is not a functional surface, but yeah, nobody gave a toss. And yeah, it's overall not, yeah, here it's even hot roll mill scale still unmachined. And the key slot is also not very pretty. Mine, on the other hand, looks pretty decent. Good finish. I took a finish pass with a reground insert. Then I polished it with the precision ground flat stones on the lathe, which gives a incredible finish and makes it very smooth. Also, I have a proper relief in here with a radius so it does not break on this point. And when we compare the two screws itself, the thread form or the thread quality, even the most casual of observers will note that this one is quite rough, and also the sides of the thread, which carry all the load, are super rough. When you screw this through the nut, you're actually machining the nut. This acts like a file almost, or like a burnishing tool, and you wear out the nut very quickly. This, on the other hand, is a proper roll formed. It's not a precision ground Acme screw, but it's a good quality piece of Acme thread, or as you call it in Germany, trapezoidal thread, Trapezgewinde. With a pretty darn good finish on the sides of the threads. And yep, this will be a very serviceable part. Okay, here's the stack up. I mounted the flange with the angular contact bearing onto the slide. Now we have a bushing that rests against the face of the bearing and acts as a spacer, and the hand wheel just pushes against the face of this bushing and gets pulled on with a screw onto the end. So there is nothing to adjust, you just screw it down, torque it down, and you're good. And as you can see, with my little modifications to the slide, it cranks now beautifully. Even as the ways are only machined on the shaper, not hand scraped. The gib is scraped, but not the ways. I need to adjust the position of this flange here relatively to the spindle nut, because feels to the end it feels a bit weird. But so far I'm quite happy how this turns out, and I hope I can get this back to the customer and make him happier with his lathe, which is important. Here you can see me checking the side-to-side play of the slide. I have the magnet up here on the top part of the slide and the indicator resting against the lower part. And when I press side to side, this is a 1/100th of a millimeter indicator, 0.01 millimeter. So what's that? Half a thou. And it barely shows needle movement, but the slide moves very freely, which I really like. And I think this will work out very well on the machine later. I decided to add oil grooves to the slide, and as you can see I laid them out only in this area, and there is a reason for that. On this particular slide, this is the only area of the dovetail that never gets exposed. It's always covered by the mating surface. So this is the area where you want your oil grooves. Otherwise, if part of the oil grooves are exposed, first of all, you cannot build up oil pressure, and the oil will just run out on the end and don't spread on the whole surface. And exposed oil grooves are always the area where dirt gets into the dovetail, because it's a it's a groove, and the groove will collect dirt, and the dirt will migrate into the sliding surface and cause all sorts of damage, scoring and galling the ground surfaces and so on and so on. It's quite bad. So I laid this out, and as you can see I have oil grooves that are square to the travel, and I have one that connects them to each other diagonal. The diagonal one is important. You could also do what a lot of machine builders do. You could do a straight one, but a straight oil groove has the problem that the area where the straight oil groove is always, it does never change. So the area of the oil groove, the mating part does not wear the same as the surrounding surface, so you're left with the stupid ridge of unworn surface in the center. And especially in this case, once you crank the slide farther in and out than the oil groove covering the mating part, you get into problem. The slide will bind up. With an oil groove on an angle, the position of the wear always changes because it's on an angle. Schaubling, for example, did straight oil lines. and when you rewatch my video of the compound slide after shoveling 102, you will see that there was a straight line of onboard surface from the straight oil groove. Quite annoying. So the better way is to do an angled oil groove. And as you can see, I set it up on the magnetic chuck because it's fast, and when I do the angled surface I just have to put an angle block behind here against the fence and I get my angle instantly without having to tilt my vise or something like that. I'm using a 1.5mm ball end mill carbide running at 3200 RPM, and I'm cutting the oil grooves 0.5mm deep. And I'm doing this all by coordinates, just reading the DRO. Okay, now to cut the diagonals. I have a weird stack up of angle blocks down here to give me 8.5 degrees, which is the angle of the diagonal. I could just eyeball it, but didn't want. It's easier to get it consistent that way, and a few parallels to space the part away a little bit. Unfortunately, I already pressed in the oilers that go in from the top, and those are a little bit proud of the surface, so I have to hang the part a little bit weirdly over the edge of the magnet. And I'm just going in and cut the diagonal. So, that's quite nice. I can turn the part around, flip my setup slightly, and cut the other one. I could cut both in the same direction, but my sense of symmetry doesn't allow for that. So I drilled all the oil passages and the holes for the oilers. On each side of the slide there will be one oiler, just like this. And I drilled them not to be a press fit, I will Loctite them in. Because when you do a press fit very close to an edge, you will distort the surrounding surfaces. This will, if you do a press fit, this will bend out. That's not something that I want, so I drilled them slightly oversized and Loctite them in. One hole goes straight through to the inside of the dovetail, or on this side to the back side of the gib. There will be a passage through the gib to the sliding side of the gib to keep that lubricated. And also a cross hole that I just drilled here on the magnet that lubricates the flat part of the slide or the sliding surface. Yeah, that's it. Okay, let's take a quick look at the lubrication of the gib. Obviously I have an oil port drilled through the gib that goes from the outside of the slide through an oil channel, through the passage in the gib, to the other side into this zigzag oil groove. And it goes together like this. Problem is, when the gib wears and you adjust it, changes its location. It goes in that way, deeper in. And obviously the two oil passages do not match up anymore. And the way to overcome this is to cut a groove into the back side of the gib that is in line with the passage. So even if the gib moves in, there is still a connection from the outside through the groove, through the passage, to the oil groove on the inside. That's the way this works. I did this on my milling machine too, and it works very well. So that's the oiling system. The original two oilers for the slideway just dribble the oil on top of the other slide, and it basically doesn't do very much. The oil might migrate over time down the gib and down to the flat part of the slide, but that's not a very good way to do it. So I decided to do two proper oil ports and proper oil grooves that do the oil distribution. And when you do an oil groove, let's draw a cross section here. This is surface of the part. We have an oil groove like this, and we have an oil groove like this. This one has sharp corners up here and here. These act like a wiper. Even if oil is in here, these sharp edges will wipe the oil away. This one, on the other hand, has a radius up here. That forms almost a wedge where the oil gets pulled into the slide when it moves, or on the sliding surface. And that's the preferred way. So you cut the oil groove with a ball end mill, or with the die grinder and a small round cardboard burr, and then you take a round scraper, a round stone or whatever, and you break the top edge of the oil grooves so they are at least chamfered or better rounded. There are books about machine design, and oil grooves and lubrication is a large portion of those books if you find one. Okay, got the slide back together, adjusted it, oiled it, mounted the handle back on, or the screw. I decided to take those two oil points out again, and I pressed into brass plugs to keep them shut, because they don't do anything useful for lubricating the slide. The oil just runs down on the lower part of the slide and migrates maybe into the sliding surfaces. So decided to remove them, plug them, flush them up with the surface so there can nothing catch on it. And those two oilers on the left and right side of the slide, those lubricate all the sliding surfaces. And this one oils the screw. I adjusted the gib as good as possible, and I have my 0.002 of a millimeter dial test indicator. That's 2 micron per division indicator here, and I'm checking the side to side play in the dovetail just by pressing side to side, and as you can see, it's about 6 microns, and that's me pressing very hard and already with oil in it. That's a good value for side-to-side play. That leaves a little bit of space for oil and makes the slide move very nicely. Compared to how it was before, that's almost brilliant. This will go out shipping back to the customer. Hope he is happy with it. I am. Nothing that I would do differently on this one. We took a piece of art and created a piece of usable machinery out of it. I'm very confident that this slide will work very well on a lathe, as far as compounds in general go. Hope you enjoyed this. This different style of rebuild without much scraping, more machining. Most of it is machining, cutting the dovetails nice and parallel. That's the most important thing to do. I would have preferred to do it on a milling machine, though, if I have to be honest. The shaper has a little problem on the accident where the cutting tool enters and exits the work. The ram of the shaper tends to get deflected a little bit. That's because materials bend, of course, and there is cutting pressure, and that makes stuff bend. And that means that the end, about 2 or 3 millimeters of the ends, are a little bit high, and you have to even out that high area with a stone if you work on a machine slide. And the milling machine has that problem not. So that's one thing to consider. Milling machine is nice. A jig borer would even be nicer. Jig borer for fine milling work would be a very nice machine. Yeah, thank you all for watching and see you next time.